Oh man, I've got. Are you okay if I write on the whiteboard? Whiteboard notes. Here we go. Okay. Today our lesson is simplifying rational expressions. All right, simplifying rational expressions. Before we even get into it, rational expression sounds like a funky thing. What is the root word of rational?
Ration.
Ration. Maybe even one letter short of ration. What would this say?
Ratio.
Ratio. Right? And what do we know that a ratio is?
It's kind of like a fraction, but not really a fraction.
No, it's totally a fraction. You're absolutely right. Sometimes we see them written in this funky way, right?
Mm-hmm.
Right, but it is absolutely a fraction. And then expressions. What does expression mean?
Like x, right? No?
Sure. X what?
It includes a variable.
X equals like.
It's not equal sign.
There's no equal sign. So like x.
Oh.
No, go ahead. So x minus 2 is an expression, but x minus 2 equals 4 is an equation. This is not an expression. An expression only includes something that does not have an equal sign. It could be like crazy. It could be like this plus 2x squared minus 12 or whatever, but it is not going to be with an equal sign.
Okay.
Does that make sense?
Yes,
So if we're simplifying rational expressions, it means we're simplifying expressions that are fractions, right? We're simplifying expressions that are fractions. So this is the type of problem where you might see something like this. This is our first example today. X squared plus 6x plus 5 over x squared minus 25. Right? So we're going to use two separate steps. The first step for today is going to be to factor.
Okay.
What are the different kinds of factoring that we've done in the past?
X
factor. What else? GCF. Good. What else?
L.
L.
Soap.
Oh yeah, like a L to take it out. Soap. Good. I said.
L. That is not what I'm. Sorry. But
Oh, I thought you were saying L.
no, like what is
L
it?
was
Least
LCM.
Oh, LCM. LCM.
Doesn't work out.
Not quite. No, that's the opposite of GCF. But
What's the O part?
which one?
The one that goes with soap. Soap is just like what to do, like how to set up the equation.
I don't
Oh,
know how to say
Ombre, there we go.
It is like X plus or minus because that's the same, right? Plus or minus whatever that is, and then this opposite.
Oh, opposite.
X squared minus X y plus y squared. That all goes with this soap formula.
Whoa.
So we'll review there when we get there. I don't want us to get tripped up on that part.
Something.
Same, opposite, always positive.
Oh, yeah.
Huh?
Good questions.
The
Yes.
one- It's like big.
There's the difference of
Quadratic
squares,
formula.
which is going to be here. Difference of squares.
What's that again?
It's like
break it down into two, so it's like x squared. I mean, it's only negative. I mean, 4, and then we break it down x plus 4, x minus
x plus, what would make
2.
4?
Oh.
X plus 2,
Oh, okay.
x minus 2, that's this one, difference of squares, which is going to come into play here.
Okay.
And then soap is for
Yes, soap is for x to the third power plus or minus y to the third power. Right, so difference of cubes. Isaac and John Parker, you got something for us?
Quadratic formula.
Quadratic formula, yes. Quadratic formula is a way to solve this type, but it's not actually a factoring method. Right? So our first step is going to be to factor. We want to break it into as many pieces as we can. So, if that is our first step, which of those methods would we need to use to factor this right here?
X factor.
X factor.
So what am I multiplying to equal?
5 over 6. 5 at the top, and then 6 at the bottom.
And 6 at the bottom, multiplying and add. And Crystal had it already, what are they? 5 and 1, we agree with Crystal's?
Yeah.
Okay, Gianfranco, how would I write it in factor form?
X plus 5, X plus 1.
X plus 5, X plus 1, excellent. You could also use the X factor for this one. What would I put on top?
25.
Negative 25,
Negative
right?
25.
Right, and what would I put on bottom?
0.
0. Why 0, David?
Because since you don't have a number in the middle that just has an X, it would just be 0.
There's no, this is technically like 0x in here, right? So then what would my numbers be?
-5.
Negative
So,
5,
when you-
positive 5.
Oh, yeah.
Wouldn't I just what, David?
No, nothing. Because I was going to say it was going to be like squared.
Yeah, this is the fast track of the difference of squares. Or the difference of squares is the fast track of this type of problem. Right? We see a square and we see another square there. So that's my first step. My first step is to factor. My second step is to cross out common terms. Okay? To cross out common terms. What I mean by that is that if something is at the top and something is at the bottom and they are exactly the same, we can cancel them. I cannot cancel x and x because x is being added to 5 in this instance. I cannot cancel 5 and 5 because 5 is being added to x. Right? So I have to cancel an entire term that is the same. Right? Do I have any terms that are the same here? Yeah, what does? Yeah, so x plus 5 and x plus 5 are the same, so I can cancel each of those terms here. That's going to be my second step. My second step is to cancel. My third step is to rewrite the leftovers. So my third step is to rewrite the leftovers. So I'm going to move here to rewrite. What do I have left over once I cancel those things?
X plus 1 over X minus 5.
X plus 1 over X minus 5. And then my fourth step is very timely considering that Endgame just came out. Don't tell me any spoilers, I haven't watched it yet.
I think one of them left.
My last step is what I've been calling the Thanos step or the Infinity Stone step this whole time. So, there are certain numbers that if you plug them into this problem, the whole problem will explode. Like when you put an Infinity Stone, things start to explode. The world starts to explode. Does that make sense?
Mm-hmm.
The numbers that we're talking about are called excluded values. We've talked a little bit about these before, but they're the numbers that would make our equation no longer work. Right? Does anybody remember what those would be? What do you got, Isaac?
Irrational numbers?
Irrational numbers? Kind of. We could put like pi in here. It would just be pi plus 1, some crazy number over pi minus 5. That's a good guess.
You said a number that doesn't make sense with it? Or
A number that will make this problem break down.
So the exact opposite of that number? So like, since it's a 5, I think it would be like a plus 5 for that X? I don't know.
Why?
Is that to get it to 0?
Yeah, to get it to 0. So excluded values are my values where the denominator equals 0, right? So let's make a note of that. So excluded values where denominator equals 0. Does anyone have any idea why I'm focusing on the denominator and not the numerator?
Because the numerator, if the numerator was 0, it would, doesn't make sense. Like, I don't know how you said it. You said it before too. You used to talk about it.
We talked about it a couple of times, but so if it's in the numerator, it doesn't
you said
matter.
it's like impossible. You can't divide nothing by something. So really nothing.
You can't divide nothing by something.
I think it's because it would be easier for you to make it into an equation. So like it'd be like X plus 1 equals like 0 or something. I don't know.
X plus 1 equals 0. Okay, we could have, it does have something to do with an equation. We could use an equation to figure it out. Let me ask this question. Which of these problems, if any, is undefined? Or doesn't work? The first one. Can you talk to me about why? Can someone talk to me about why the first one is? You can't divide by 0. Why not, Caesar? You just can't. Can anyone think about what that would look like? This is like you have two things. Let's see, I have two calculators. And I'm trying to put them in 0 groups. Can anyone take these two and put them in 0 groups?
No.
The only way you could do it is by destroying them, right?
Right.
The laws of physics say that even if we destroy them, that mass still exists somewhere, right? So like there's no way to take something and turn it into nothing. right?
There's only two.
Is there a way to take nothing and put nothing in two groups?
No.
Here I have nothing. Here's nothing in my hands.
But you,
And I'm taking nothing and I'm putting nothing in two groups.
so you have nothing in two groups.
I just have nothing, right? I have nothing in each group. So that first one, what's the number equivalent of nothing? 0. So the first one is undefined, but the second one is 0. Esther, can you put in your own words the difference between this first one here and that second one there?
Yes, the first one, nothing can be multiplied by 0 to give you 2.
Oh, okay.
And the second one is 0 divided by 2 is 0. Anything divided by 0 is 0.
Anything divided by 0 is
That's
0?
the second one.
For the second one. So do you mean 0 divided by anything?
Yeah.
Is 0?
Yeah, so
So this number doesn't mean. We can make a rhyme.
Try to make it a rhyme for people that
Should we make a rhyme? What are our rhyme?
No.
don't think you.
Okay, Kristen will come up with a rhyme and she'll let us know.
No, I just,
Oh, you
it
could
just rhymed a little bit.
It rhymed. It did.
A number over
Took away.
wait, a number.
Taz is gonna
Wait,
get
hold
it.
on. A number of 0 is undefined. A number over I don't know.
Okay, we'll think about it. We'll think about it. But it did a little
Oh
bit.
wait. Hold on.
So,
A number over 0 is undefined. 0
Don't-
over a number can change the line.
You're annoying.
okay,
Bye.
that's weird. Okay, so which of these is the problem? Is this a problem? Like for the actual solving. Are we allowed to get 0 as our answer?
Yes.
Yeah, we can totally get 0 as an answer. Undefined is a bigger problem for us. This is the Thanos situation that I was talking about. If the bottom is 0, the problem explodes and it becomes undefined, right? So we're trying to find a place where this would be undefined. And David put a number out there. I don't remember what number it was. What,
I said 5.
5. If we put 5 in here, right, this problem is no longer going to work. 5 minus 5 would be 0. So this problem no longer works. I'm going to argue that there's another number, and the other number is negative 5. Does anyone have any idea where I got negative 5 from? If I put negative 5 in here, is that okay?
Yeah.
Negative 5 minus 5 is
Negative 10.
10. That's fine, right? What about if I put negative 5 in the original problem?
0.
No,
That
I think
makes
it's
zero.
still.
Oh,
Right.
that means 0
5
and 0
plus
times
5
that
is
is
zero.
still gonna be 0.
Right.
If I put negative 5 in here.
Oh, because then
Times.
Because then, yes, because then 0 times this, whatever that is still 0.
So
So
when
when
we
I-
simplify, we still need the top number anyway.
Yeah, good question. Like, why do we still have to look back at the original?
Yeah.
Is because when we are talking about excluded values, we're talking about excluding them from the beginning. Where it's like, if we take 5 and put it in here, what's 5 squared?
25.
Minus 25 would be 0, right? What's negative 5 squared?
25.
Still 25 minus 25 is still 0. So we're excluding them from the original problem. We're excluding them from the original problem. I know it's very complicated.
Okay, no, because so you need to tell me we could have just did X. We could have just got the X's from that top from step 2.
Yes.
And we would have solved it, right?
We could have absolutely gotten them. Well, we wouldn't have solved it necessarily, David. We still would have needed to do the canceling part. But we absolutely are always going to get our excluded value from step 2.
Okay.
Right? So maybe let's add that
Wait,
here.
what symbol is that? Or is that just
Which symbol?
I see it. Never mind.
It's a not equal to.
But why is that slash the equal sign?
Oh wait, it's a what?
This symbol right here is an equal sign with a line through it. It means cannot be equal. We are telling the readers, if this was like an audience, we're telling the readers that to be careful. Like, this is the simplified version, but be careful, X is not allowed to be 5 or negative 5. And that negative 5 is really important because it's pretty obvious to us why 5 doesn't work in this section. But if you just had this part, you wouldn't know that negative 5 was also canceled out earlier in the problem. So first step was here when we were factoring. Our second step was here when we crossed things out. Our third step was here when we rewrote it. And our fourth step was here when we looked for our excluded values. what questions do we have about the process? Any so far? Do we want to try another example?
Yeah.
Okay. I have 2 more examples for us. I think it will solidify our knowledge. I'm gonna erase this. Okay. The next problem is, go ahead and section off your paper, get yourself organized in your notes. Next problem is x to the third plus x squared over x plus 1. Alright. What's our first step? Anthony, what's the first step? Factoring. Factoring. So what does it mean to factor in this problem? Is there anything we can factor?
No. Yes. No? I don't know.
What's that? The x's. What do you mean by that?
I was gonna ask, for factoring, you can also do grouping.
Can you also do grouping? You can do grouping. How would you do that?
Like you have pair mentality, but both of them have in common.
Is on the
Just
numerator?
Yeah,
Okay, so what would you take out?
x squared.
They have x squared in common. So what you're talking about here, Anthony, is the GCF. Is GCF. You can use grouping. They're very similar to GCF, right?
What's
We'll
grouping?
put those together. Grouping is where you have the 4 and you factor GCF out of the first 2 and this GCF out of the second 2.
Oh, and then you have the 2 different x. Oh, okay.
Yeah, exactly. So then, Anthony, what would be left over?
X.
X what?
Just
I see that there's a plus sign. No, I know that it's
X plus 1.
there we go. Good catch, team. So I still have x plus 1. Is there anything I can do with x plus 1 on the bottom?
No.
No breaking it up. Okay, so step 1. Step 1 I factored. What's step 2?
You have to
Cross
cross
out.
out.
Cross out. Do I have anything like,
Yes.
what are they?
X plus 1.
X plus 1, x plus 1. Okay, that is my step 2. What is step 3?
Rewrite
Rewrite the leftovers, which are what?
x squared.
X squared, good. I'm gonna put a comma, because a comma is how I note that there's a warning about to come up.
Okay.
Alright, so I put the comma, and then my warning is
You value x.
Excluded values.
excluded values. So I wanna tell the reader what x is not allowed to be. Where do I look to find my excluded values?
Step 2.
Step 2, so I'm looking up here. Do I look in the numerator or the denominator or both?
Denominator.
Denominator only. Because remember, Tazzy, it's okay if 0's on the top,
Yeah.
right? This is okay. If 0's on the bottom, we have a problem. So we're looking in our denominator. And what would make the denominator 0?
-1.
Negative 1.
That's it?
That's it.
I'm not pushing something.
That's the x.
Wait, well, why I guess I'm kind of reading to cross out because you're still gonna need the 1 before. You're still gonna need that x plus 1 to cross out. So no way cross out. Like I don't feel like there's a reason to rewrite the left one. Because you're still gonna go back to that.
So, Crystal, the answer is not this. The answer is this. So this is a simplified version of this. This is a great question, and I should have probably thought about this more.
Because now I'm like.
This is the answer. Right? So we're taking this and we're making it smaller. The reason that we're including the excluded values is because this is not equal to this at -1.
Oh.
That makes
I
sense.
didn't even think about
There it was,
that.
Crystal. You are in charge of both of those O's. That was awesome. Those were for you because you asked a great question. Is that making more sense?
Yes.
Okay, so this is now the simplified version, except simplified, except when it's here, except at -1. Because at -1 it is not true.
Yeah.
Great question. I'm glad we got there. John Franco, any questions? No? David?
I got a question.
Yes, ma'am.
Why so far?
Cause I can see better back here.
Alright.
The, why you get the negative one again? Just run that down.
Yeah, I've said it a couple times. Can someone put it in their own words?
So basically, oh, go ahead. Oh, the reason why she put a -1 is because you're saying that what we're basically saying is this is the simplified version, but you won't get that if the x is like this number. So basically, you can't have -1.
Placed into x.
Right.
Placed into the bottom of x.
Cause it would be 0.
Right.
Yeah, and 0, and like if you like writing it like 2 over 0, that's undefined. So that doesn't work in the equation. Like, so that equation is not equal to x squared if you put a -1 in there, because at the bottom it'll be 0, which will make that whole equation undefined.
Okay, what if it was like more than one number that will get you 0?
Then it's over
Then you
there on
write
the
them.
first one.
Like how this one had 2, we had to write down 5 and -5. So you write all the excluded values, all the values that will make the denominator 0. Because if you make the denominator 0, the equation won't be true to that answer.
But the way that's gonna help you get that x can't be this is if you go back to step 2. Because if you don't go back to step 2, then you're gonna be like confused.
Yeah.
Okay, thank you. I think some merit should be earned because I know I understand.
To whom? To whom?
Both Tati and Jada. I mean, Tati and David. I'm sorry, that's hey.
Alright. Good job, good job. Alright, let's look at the last
I was getting in
example.
trouble.
4x squared plus 4x minus 24 over x squared plus 3x minus 10.
Ugh.
So we'll take it one step further. Example 3.
But if we say, wait, how does it, when people say like 2 over 3, what do they mean on the part? Like 2 over something, right?
They mean like 2
Like
groups?
while you're teaching, I'm making a word.
Do you want me to try it right now?
No, I just like, if I say 2 over something, I want to like 2 over 3.
No.
2 over 3.
Okay, I just want to make sure because I'm confused.
Yep. Same as 2 divided by 3. Okay, or 2/3. Okay, so first step is what?
Factor.
Factor. Alright, first step is factor. What do I do?
For the top, I just did GCF.
You took GCF out first? Good luck. What was the GCF?
4.
4. So when we take out 4, what do we get?
We get x squared
plus x
Minus
6.
okay, 6. And then I still have this. Okay, cool. So I have top and bottom. Can I go further?
Yes.
Okay, how?
You can do the top by doing that.
Wait, Tazzy, what?
Go ahead.
Okay.
I was thinking that you can do the x factor for both of them. So they
X
can
factor for both of them. I'm gonna switch colors here.
top and the bottom.
Okay, so for the top and for the bottom, 2 X factors.
Mm-hmm.
Okay, so what do I have?
I didn't get that far.
What number do I put on top?
-6,
-6
1.
and 1.
So then it'll be -2 and 3.
I have 2 and 3 and 5 and 1.
Never mind, that was so wrong.
Not 5 and 1. Taking it back. So 2 and 3.
Yes, and then the 2 would be negative.
Do we agree with that?
Yeah.
John Franco shaking his head. Yeah, Esther, you agree? Okay. So then what would I write as my numerator here? 4 parentheses.
Negative, wait, x minus 2 and then x minus
Plus 3. Good correction. And then on the bottom, what do I do?
You would do it. That's fine.
X factor again, so -10, positive 3.
5, -3.
What is it, John Franco?
Never mind.
5 and 2. 5 would be I mean, the 2 would be negative 2.
-2.
The 2 is negative? Okay. So what would I write here?
X plus 5 and x minus 2.
X plus 5, x minus 2. X plus 5, x minus 2. Perfect. Okay, so first step completed.
Then you cancel out what's the same.
Cancel out what's the same.
So
Same where?
And
At the top
denominator
and
and
the
bottom.
Top and bottom. Anything?
So
Yes.
x minus 2.
X minus 2 and x minus 2.
Then you bring down the leftovers. So
Okay.
you have 4 in parentheses x plus 3 over x plus 5.
Okay.
And then
No.
no.
It's
And
close. We're on step 3. What's step 4?
Oh, now we do
then
it.
excluded values.
Excluded values. So x cannot be what?
-5.
-5 And
And
Can I
positive
say
2.
two?
and positive 2.
Yeah.
Yes, Crystal, you can totally say 2.
But you forgot about the step
We
2.
have to go back to step 2.
Oh.
Because remember that if we put 2 in here, let's just go back and put 2 in here. 2 squared is 4, plus 3 times 2 is plus 6, minus 10,
Oh.
minus 10, 4 plus 6 is 10, minus 10 would be 0. So 2 would be a problem as well. So our excluded values always have to go back to step 2. Always back to step 2. Now are we done?
Yes.
Yes, we are done.
We're good?
We are with our notes. Give me 1 second to reference. So with your, don't stop filming. Okay, with your
Oh, you're filming?
packet here. Yeah, she's been doing a great job. Thank you, Daisy. With your packet, you'll see that you have bronze, silver, and gold on this lesson. The bronze should be very, very fast, like no more than 5 minutes. Right? The bronze is only 3 problems because you're doing 3 and your partner's doing 3.
Okay.
If you choose to not have a partner, you have to do both sides.
Cool.
Right? I will sign you off. Okay. For silver, there's a couple pages, right? But I just made your boxes really big because I know we have some big writers, right? And then for gold, you have a choice.
Okay.
Gold is on page 5. You have a choice on which of the problems to solve.
Okay.
So those are a little more difficult. It increases in rigor, right? It increases in rigor, but you have bronze, silver, and gold. Other questions? Cody?
I'm sorry, it's not regarding to what you just said.
That's fine. What's up?
But the bottom, okay, so if the denominator, it's just gonna be basically the opposite of the solution that we got.
Exactly. So it's actually basically the solutions of the denominator because the solutions are what makes it 0.
Right.
Okay. Yes, good question. Are there any questions about your assignment today?
Is this our homework?
This is our homework. You should be done with bronze in the next 5 minutes. I'm gonna put on a 5-minute timer to get us there. You should be done with 5-minute bronze. Silver might take you the rest of the period, and then gold should be your homework. Are there any questions about timing or pacing? Okay, let's rock it out. I'll put on 5 minutes. Thank you, Daisy.